Hi all, and welcome to our last meeting of the year, the December meeting of the New York JavaSIG. Today's topic is harnessing the power of AI and OpenTelemetry for continuous feedback. But before we get started, we have an announcement/commercial from one of our other leaders.
Am I on the camera? No. Public service announcement, Drew University, where I work, and the town that I live in and all that. We're looking for somebody to teach operating systems in the spring, an operating systems course for undergraduates. We'd prefer in person. We'll consider online if we don't find a qualified person who's in person. But if you know of someone who might be interested in an adjunct position for a semester in a class in a wonderfully friendly and wonderful and terrific and nice looking campus and all that great stuff, then please let me know. Send your, talk to me if you're here in the meeting. And if you're over there on YouTube, info@javasig.com, right?
Yes.
Very good. Okay.
Excellent. Thanks, Barry. Today's speaker comes to us from the Bay Area. Ronnie Dover is a developer at Digma. Digma conveniently paid for the pizza that all the people in the room with me are currently eating. Thank you for the pizza. We also wish to thank BNY Mellon for this room that we're sitting in that has electricity and Wi-Fi. The Wi-Fi connection info is on your badge. And with that, I would like to call up our speaker. Welcome, Ronnie.
Hello, everyone. Sound check. Am I okay on that side?
Yeah.
Perfect. So my name is Ronnie, and I'm here to talk about continuous feedback. And if you have not heard about continuous feedback before, then I want to say two things. First of all, that I did not make up continuous feedback. It exists, and in this session, I will prove it to you that it's not just some wild thing that we came up with. It actually was there all along. And second, I hope that by the end of this presentation, I will also have convinced you that continuous feedback is extremely important to know about as well. And we'll also talk about OpenTelemetry. So a few things about me. I've been a developer for the last 25 years or so. I started out with Java. It was my first language. It was in the merry days of J2EE and enterprise Java beans. Somehow I survived these days and lived to tell the tale, but I can only say, having returned to Java recently, that it's quite a changed language today from the one that I remember when I first started. So back in the days, it was just a lot of XML and basically XML programming and doing a lot of boilerplate and configuration. And it's great to see that it's completely different. But one other thing about me is that I never quite found my place between being a developer and being a product manager. So when I was developing, I was also always asking like these inconvenient questions, like, why are we building that? Who is the end user? All right. Oh, it should be this one or this one. Better? Okay. So.
Are you sharing on Zoom?
I would think so, but perhaps not. Let's make sure that I am. Oh, okay.
There we go.
This should be better.
Wonderful.
Perfect. So apologies if you did not see the previous slides. So being a developer, I always cared about the whys and the use cases. And that got me into a lot of trouble because the product manager would kind of see that as an kind of stepping on his toes. So eventually they made me a product manager. The problem with that was that yes, everything okay? Okay. The problem with that was that I couldn't quite deal with not coding. So I continued to write code in the middle of the night, and it's kind of not fair when you're both the product manager and the developer, because you can kind of code up your own fantasies. And as a result of that, the engineering team started revolting about somebody introducing features they never knew about into the release, only to find about them on release day. So they took away my product management license, and they put me in the engineering trenches again. And so I kind of went back and forth between these two extremes. But I think the important thing is that throughout that journey, I was really, really obsessed with what's the best way to develop and what developer processes work for me as a PM and work for me as a developer. And throughout all of that time, these last 25 years, coding practices really changed. And how many people here have been a developer for more than 10 years? Okay. How many more than 15 years? More than 20. So quite a lot, as we can see. So you know what I'm talking about, because when I got started, our GitOps process looked like this. Essentially, we would work on the release, we would burn it onto a CD-ROM, and then we would just hand it over to the guys across the hall called the QA department, and they would take it from there. And this was great, and sometimes we heard back about our features, and sometimes we didn't. But of course, it was great to see that things evolved. And today, when developers write code, they need to worry about much, much more. So if I have a developer in my team that would hand me a CD-ROM, I would not know what to do with them. But if they do want to be a productive member of the team, they need to master unit tests, integration tests. They need to know about the deployment of their service, sometimes understand Helm and Terraform, and basically have this holistic understanding of everything their code does. So this was great. I was thrilled to see testing were catching on. It was great to see people adopting Agile and moving in that direction. But there is still something about this specific diagram that kind of bothers me. And we'll kind of get back to it throughout this presentation. But one question I want to put out there is, what happens next? So we have here this linear process, right, which is weird by itself because we're talking about the DevOps loop, right? It's supposed to be more of a circular process. And at a certain point of time, we've created our PR, we deployed it to production. We merged our pull request. It will get deployed to production, hopefully automatically, maybe manually. What happens then? What is the first thing you do after you've merged your PR? What is it? Okay, and then it failed, and then you fixed it, and now it's in. Now what do you do? Any thoughts? I'm sure it's something you do all the time, right? The minute after you merge your pull request. So kind of hold on to that thought, because we'll be coming back to it. It kind of touches on the very basic thing I'm talking about. So all we talked about just now is how we developed until now, but of course technology is changing again. And today we can do a lot with AI. We can generate code really fast. That is, at least I've been using Copilot a lot. Have anybody here used AI generation in coding, writing tests, and so on? So I use it a lot. I use it to generate code. Often that code is worthless and I delete it, but it gives me a basic understanding of what I'm about to do. It gives me kind of a straw man to work on, and it's actually pretty useful. However, all of this AI is just helping us code faster. That doesn't necessarily mean that we get a lot of feedback back. And if you think about it like that, there is output and there is input. So on the output side, we're great. We're generating a lot of code. We're generating it faster. On the input side, not so much. And to kind of give a way to visualize it, how many people here are doing continuous release or continuous deployment? Not a lot. But throughout the last years, releases have become much more rapid. So there's been kind of a pressure for developers to release more often than we used to. And the thing about releasing more often, and I've experienced this both as a product manager and as a developer, is that if you're not getting any feedback, all you're doing is essentially throwing features over the fence at a higher rate or a higher velocity. If all you're doing is throwing features in one after the other, then, and you're not getting any information back about what's happening, then eventually what will happen is that things will start melting down because you did not actually get the feedback that you need to build them correctly. And I was in a team that experienced just that. We were a team of about 10 people, and we called what we were doing BDD. And I'm not talking about behavior-driven design. I'm talking about bug-driven development. Because essentially all we were doing is throwing in releases. Eventually it came to a meltdown. Then we were in fire brigade mode, kind of running around, fixing issues all the time and context switching. We were not being efficient. And this goes back to my own personal kind of fixation on finding the right dev process, because that one, just optimizing for speed, didn't seem to work. So going back to how we can leverage tools like AI, it's one thing to use them to write code faster, but then understanding the code better, that's another thing entirely. And this raises the question, which also goes back to that previous topic of what do we do the minute after we deploy to production, which is what do you actually know about your code? And that sounds like a dumb question, but it's actually pretty fundamental. What do we know about it? What is the scope of what we know about our code changes and whether they're good or bad, whether they're improving the application or not? And I can think of several things that I know about my code. I debugged it, and I saw it with my own eyes to see that it's running or working. Sometimes I write tests. Often I write tests, but these tests are pretty limited because tests tend to be very biased, very narrow in scope, and they kind of code more to my assumptions than anything else. So I know my assumptions work because I've coded for them. But what else do I know about my code? And what happens when I don't know enough about my code? So I'll give you an example. In this spectrum between knowing exactly how your code works and how it transformed the system and how it's connected to everything else, and just knowing what happened once you deployed it, I encountered a situation where a developer that I worked with worked on a very important update for months. It was an update to the data access layer. He added this extra layer that was supposed to improve performance immensely. And he pushed that code in and moved on to the next task. Because his answer to the question that I asked you before, what do you do the minute after you deploy to production, was, and this is the answer I get from 99% of developers that I talk to, move on to the next task. So he did, he moved on to the next task. And about a month later, we found out that his code never ran in production. And the reason it never ran was because of kind of a bad if statement. So here is this developer, and he wrote this amazing piece of code, and he deployed it, and he forgot about it, and it was never running. In this kind of spectrum that I described between knowing so much about your code and knowing whether it even ran, he was not even in that position of knowing whether his code executed. So I took that developer and I took him aside and I told him, look, you're doing a great job. You did this amazing piece of code. How come you didn't check that it's actually running in production? Now, his response made me take a step backwards, because he told me very blankly, well, how? How was I supposed to check that? What should I have done? I just rolled out this piece of code. What should I have done to check, as you're saying? And I didn't have a good answer for him. And this is a part of what prompted me to think about the fact that there is a bit of a missing piece here in this linear development process that I just described to you. Because if at the end of it, you don't know even whether your code is running and is being used, I'm not even talking about whether it caused a regression or how it is being used, then we have a problem. And as a product manager, I was kind of making the problem worse, because I was very pressing in terms of moving the needle forward. So like no product manager in the history of software development, well, maybe one, but I would like to shake his hands when I meet him, has it on his roadmap that, yeah, we're going to roll out the users feature next month. And then months after that, I have this slot for collecting feedback about it, right? That doesn't exist. So as engineering organizations, we're forward-leaning. We're always thinking about the next feature. It's not just the developer that deployed and ran off to work on the next task. This is what he's pressured to do. And this is what me as a product manager was also concerned at. So nobody was thinking about feedback at all. And this is how that whole incident came about. So the problem is we don't get back information about our code, so we don't know it very well. And then what happens is problems start coming up, and then it's the middle of the night and we just need to figure it out. And we don't know why things stop working, and we don't know why there are timeouts all of a sudden. We don't know why the queues are exploding or why RAM consumption is going wild. And we don't know all of those things because we're missing critical information about our code. And then we need to start troubleshooting. And there are lots of great tools for troubleshooting. It's just that if you're troubleshooting, you're kind of doing things a bit too late. And this is also my big frustration and concern about monitoring as a practice. So monitoring is great. Please monitor your application. But if your monitoring alarm bells are going off and they're saying there's a problem in production, you're detecting it way, way too late. The damage is already there. You've already introduced things into the code base. These things are already running, and you're way too late to this party to start figuring it out in a calm way that wouldn't hurt team efficiency. So I want to tell you a story about a developer that I know that did something amazing, but also did something terrible that I don't recommend that you do as well. And I don't believe in a 10x engineer, but I think this particular developer has that capacity to become one. And the story goes like this. I was working on some piece of code, and suddenly I noticed that my output and my logs are completely being spammed by numbers. It kind of looked like the matrix, 60, 40, 50, 70, 80, 30. And it was completely overrunning the logs, the output, everything. And I traced it down to a particular commit by one of the developers. And I go up to that developer and I'm asking him, okay, are you kind of, are you testing us? Is this kind of, does it serve a purpose? Why are you writing all of these numbers now? So he says two things. First of all, he says, I apologize. I didn't mean to check this in. I was running this locally. But what I was doing is the following. I am working on a batch job on this background process that analyzes does some data aggregation analysis and completes the loop. And as I was coding, I was becoming concerned that the code that I was adding might be causing a regression in terms of performance, because I know this needs to be effective, and I wanted to make sure that the throughput isn't compromised. So here's what I did. I printed out each time this batch job ran how long the loop was taking. And I was monitoring this in my peripheral vision as I was typing. So I was using this kind of a spider sense to sense if suddenly there were too many 70s and 80s and too little 50s and 40s, then I knew that I caused an issue. So the first thing I would like to say about that is please don't do this. But here was a team of 10 developers, none of which had that sense of ownership to actually think of that about their code. So this is not about this is how I envision the difference between continuous deployment and continuous release. He was not concerned about deployment. Deployment is easy. Anybody can deploy. He was concerned about what is the state of the release that he's creating. So as he was working on it, it wasn't enough for him to write the code. He also wanted to understand how it will impact the system at large. Now, the problem is that he had the absolute wrong tools for the job, right? The console is not your friend for this. But imagine if it did have the right tools, then he would really stand out in that team because he would be the developer who actually rolls out performant code. So as I was thinking about this, and this is kind of the second moment of revelation that I had, I was thinking about what if we had the right tools? What if we somehow did have a way to measure this more effortlessly? And if we could create that feedback where it's missing. So what we saw is that this developer was actually writing code. Supposedly he had feedback because he was debugging. But think about it. Debugging is like the worst way to get feedback. You kind of put a breakpoint and it's a minute in time and space that is not necessarily at all indicative of how the system is performing. It's just this one thread that you caught on a bad day. And at the same time, we do get test feedback, but we mentioned how that is limited and biased often, and we get no production feedback. So how can we actually counter that? And this is where I turn back to the DevOps loop. And, you know, this model is by now, I think, completely overused. And by the way, this diagram is one of the first pictures that will pop up if you search Google Images for the DevOps loop diagram. Now, I was looking at this, trying to find the answers, and I think that if you look at it as well, you might find that there is something completely off with this diagram. And I'm going to give you a few seconds to look at it and tell me what you find out. And if you do see something wrong here. And the first person is going to win a Digmo, which is our mascot that was designed by one of my developers. Anybody notices something wrong here? And I'll give you a clue. It's right at the center of the view. It couldn't be more in the center.
Is it that continuous feedback is a step instead of something that happens all the time?
So close. Look at the tools. Yeah.
Maybe continuous feedback is broken when we push to prod and there is no more loop.
So you're all very close. Which tool is it? Yeah,
There's no tool there for continuous feedback.
exactly.
Woohoo.
Oop. So exactly. The problem is that I looked at this diagram and I saw this amazing wealth of tools that we have for each of the stages in the DevOps loop, and you were all kind of spot on. There are a lot of continuous integration tools, there are a lot of deployment tools, operation tools, and so on. And here is where I get to the part where I prove to you that I did not make up continuous feedback. It's not an invention of mine. It was there all along, and it's been staring at us across DevOps loop diagrams for more than 10 years. It's there. But then when the author of this diagram, and you'll see this problem repeat itself in other diagrams as well, thought to chart out which tools belong in each step. For some reason, the only tool that made sense to him to put under continuous feedback is Salesforce, which I did not get. And I actually sent this guy a note asking why he chose Salesforce. If you know him, ask him as well. But be that as it may, as you say, it just means that there are no tools there. We're great at, and you know, if you think about it, it makes a lot of sense because as a product manager, I care about the next feature. I care about speed. I care about velocity, releases. Feedback, not so much. And therein lies the problem. And that's a great segue to talk about OpenTelemetry. So how many people here are familiar with OpenTelemetry? Oh, nice. How many people use OpenTelemetry? How many people here use tracing? Not so much. Okay, somewhat. So don't worry, I'll kind of give an overview of tracing in general and OpenTelemetry in general before I dive in. But I think a part of the point of this presentation is that I think you absolutely should not know anything about OpenTelemetry, because the goal of OpenTelemetry is not to be a technology everybody knows. It's to become transparent and just give you value. Just like you don't care about like which HTTPS encryption you're using. Who cares, right? You get a secure connection. That's the goal. So why is OpenTelemetry important though? And having kind of talked to a lot of the guys who are working on OpenTelemetry, I can say two things. First of all, OpenTelemetry is absolutely not a groundbreaking technology. It's not a revolution, it's an evolution of a merging together of two previous standards, OpenTrace and OpenCensus. And it doesn't bring anything, you know, spectacular and amazing that we should all kind of be awestruck about. But the number one thing that is the most important thing about OpenTelemetry, and the reason I'm extremely excited about it, is because something happened with OpenTelemetry that hasn't happened in a while and sometimes never happens with developers, and that is that everybody agrees on it. So here we are with a spec that everybody considers to be the de facto standard for observing your code. And why is that beneficial? Because it means that if I'm writing a library, Spring or Quarkus or JDBC, or if I'm working on Kafka or Rabbit integration like this, it doesn't matter which library I'm writing. I know that to support observability, I'll just support OTA. And what that means, and we'll take a look at that in a second, is that from a developer point of view, all of the libraries that you guys are using, or at least a very large percentage of them, they already support OpenTelemetry. And that means that to go from zero observability in your project, you never thought about observability, you never invested in it, to having almost too much, in fact, too much information about your project, is a flip of a switch. It's kind of, sometimes it doesn't even require any code changes. It's something you can do right now when you get back to your laptop by enabling a few environment variables, and you'll have all of that information because all of these libraries that you're using, they already support it. And this to me is groundbreaking. And it's groundbreaking to me, especially as the product manager who always failed to prioritize observability initiatives in the backlog. Because this is not a big initiative that we need to scope and give people time to work on it. And it's never the right time because there's always this pressing release that we need to focus on. No, this is something we can just do without thinking about it. And we'll talk about the small print. So tracing. For those of you who are not familiar with tracing, tracing is just a nice way to visualize what your code is doing. Kind of an anatomy of a request or of what happens when your code gets triggered. So, for example, here I have a modified version of the Pet Clinic app that I'll show you in a sec. And what we're seeing here are the stages of handling a request. So we have Spring Boot, we have an external API we're talking to, we have Postgres using Hibernate. And all of these libraries are already emitting information about what they're doing. And what it allows us as a developer is to see the entire outline of the request. And this includes both information that we can provide and what the libraries are already providing for us. So, and the amazing thing is that this works across microservices. There is context propagation across microservices. So I could have a distributed trace that shows me everything that happens when a specific request gets handled across microservices, across libraries, from the queries that gets triggered to the HTTP calls that are being made to queue events, everything. And this is what it looks like. And we'll take a look in a sec, but I can visualize it. And there are amazing open source tools to do that. This is Jaeger, for example, that allows me to see exactly what happened when I made a specific request. Now, before I go to show you, because we've been kind of in PowerPoint mode a bit too much, does this look useful? Can you think of a way in which you would use this capability of understanding what happens when a request gets triggered in your day-to-day coding? Raise your hands if you do. Right? It looks a bit finicky, right? There's a lot of information here. So let's try to understand whether this is something that can actually be useful to us. So I have here that same pet clinic project that I was talking about. And because I had some time over a plane ride, I decided to add something to it. The reason is because Pet Clinic is kind of a CRUD app, and I hate CRUD apps. So I decided to add some asynchronous processing or functionality. I decided all pets have vaccines. Let's create a vaccination API that holds some data. Let's call that asynchronously to update the pet vaccination information and then display to the owner whether his pet needs a vaccine. Okay, all in all, pretty simple. I was using all of the libraries. In order to get this instrumented, all I had to do is this. You can see the topmost box over here where it says export Java tool options. I'm using the agent, the OpenTelemetry agent, because it's only in dev and test. So there is no worries there. I mentioned what is the name of my application, and then I just run it, and I just modified my run config to include that environment variable. So just to emphasize, I did not change my code. I did not add a dependency. I did not do anything that anybody would actually notice. I just, in the way that I run my code, I'm running it in a way that would emit information. Now, I wrote this code that...
Question about those two variables you just, or system properties you just showed. Are those standard names, or are those things your code is written to recognize?
These are just environment variables.
Right. But does your code know about those environment variables, or are they
absolutely not.
standard?
These are JVM options. One would... Sorry? Yes, your service name is just a way to identify your application with as a scope in the trace. So you want to know which microservice is which scope for handling the request. So that's it. I set the environment variables, and I'm good to go on that front. But I want to tell you a little bit more about the code that I added. So as I mentioned, I created a mock API. There are a lot of websites that help you do that. I'm using OKHTTP to do that. I created this facade that allows me to access the vaccination information. I feel pretty good about the code that I wrote. And here, I want to take you back to the original premise of what do you know about your code? Because I have exhausted every technique that I have. I wrote this code. I love test containers, so I wrote some tests using test containers. They're all green. I have a code review done by a peer who said, you know, I have a lot of things on my mind, and it's nice that you gave me 50 files to review at once, but I'll do you a favor. And he went over them and he said, it looks good. I have nothing to add. So in terms of what do I know about my code, I have exhausted each and everything I have at my disposal. If there are any other suggestions from you, I'll love to try them out. But now, let's see what other information I may have that I may not know about. So as I'm debugging my code, I'm running it, right? Because one of the things I want to do is either run tests or see with my own eyes that my code is working. So I'm running my code here. As you may notice, there are a few lines here that are basically telling me that it's picking up the OpenTelemetry agent, which is great. And now let me show off this amazing piece of functionality that I wrote. So this is the pet clinic app that I did not write. However, I can go for a specific owner, for example, this person, and I can see whether they need a vaccine. And this is because I'm doing some processing when I add a pet to check their vaccination status and when their vaccine is due. And I added a few tables to store that information. And I can also kind of add a new pet. Let's say it's a dog. And that's great. It was pretty smooth, right? You did not notice a delay in the processing, right? And it looks like I'm ready to check in my code. So let me pull up the traces that showed me exactly what happened as I was using my code. So before I do that, I have a question. Is anybody here using Hibernate? Not so much. Okay, cool. I'm sorry. So this is my Jaeger instance. And I can look up exactly these requests that I just made. And you can see kind of the post request to create the pet and the get request to see the owner. And let me pull this up. And I'm going to make this just slightly bigger so you guys can see. So just by looking at it, is there anything that jumps to mind to you guys as being wrong about this trace? Yes?
A lot of sequential tasks.
A lot of what?
Sequential tasks.
Sequential tasks?
Yes.
What else? So how about the queries there? Like what's going on there? You see a lot of queries going on, right? So I can kind of notice that. And if I go in a little deeper and see exactly what is happening, I have a full view all the way to the query level. I can tell you that what is happening behind the scenes here is known as an n+1 select query. And anybody who uses an ORM will be familiar with that. Essentially, what it means is that because of bad modeling, I'm lazily accessing a relationship in a way that just causes each member to be loaded on its own. So if I have, in this case, I think it's the owner visit, or maybe it's the new table that I wrote for vaccination. For each vaccine, I'm making a separate query. So this would jump out to me because I've seen this issue a couple of times. To tell you that it would immediately jump at me, maybe if I'm an expert. But let's continue looking at this trace because this is interesting. This is information that I did not have before. So the other thing that jumps to mind here is this section here. So all of these information I got for free. I did not do anything to get it. I just enabled OpenTelemetry. And what we're seeing here is that Spring is telling me it's running its rendering stage. So this is the rendering of the owner details view. And what we're seeing here is that as it's doing the rendering, it's also triggering SQL statement. And if I look at which SQL statement, it looks like it's triggering calls to the pet vaccines table that I created. And this is known as another anti-pattern called OpenSessionView. And what it means is that because the session to the database is kept open and you're lazily accessing a property causing or triggering a SQL statement, you're basically hitting the database while you're rendering, which is considered a no-no. So two things that jumped out at me when I was reviewing the trace. Could I have seen them before? Probably not. Would I see them just by looking over the trace? Not so much, right? But suddenly, we're at a different problem. Before, the problem was we have no information. Remember what the developer told me when I asked him if his code was running? He told me, how do I check? I don't know. So here is a way to check, right? Because I can see my own code. And by the way, one of the nice things about OTel is that you can add your own traces. So I can see where my code is running and I can find out things about my code this way. The problem is that it's almost too much data. Because remember, I was just looking at one trace, one instance. If the problem has happened in trace number 5,722, I would not catch it. Let's look at my other action that I implemented. So this is the post request to create the owner. This is where I'm making that magical HTTP call to get the vaccination status. It looked to be working very nice, right? Because it was asynchronous, but it was also pretty smooth. Let's look at kind of what's happening around here. So it looks like I added one pet, and then there were multiple calls being made to the API to get it. Now, that doesn't make a lot of sense. And I can tell you after I investigated the code that it was my fault. I was iterating over a collection of vaccines and I was trying to get more information about them instead of doing things in a more efficient way because I was trying to match it up to the pet ID. But the problem is that this was completely invisible to me as well before I looked at the code data. And this is how bugs get into production that nobody can figure out how to detect earlier on. So what did we see? We saw that all of the information was there, that to enable it, all I had to do was to change a few environment variables, and all of a sudden I have this wealth of information. But we also saw that it might not be enough. And I'll tell you in a sec about what happened when I tried to take this tool and go back to the developer, to that 10x developer, and told him, this is the tool you need to use. And how did that experiment work out for me? But before I do that, just to assure you that I'm not being lazy and kind of not going into the nitty-gritty of all of these tools and how to get them to work, I don't think, so this isn't an OpenTelemetry 101 presentation. The reason it is not is that I don't think we need one. There are a lot of tutorials. It's very easy. As you saw, just a few environment variables. This Jaeger tool is just a container. However, if you are interested in all of those things, I created a website called continuousfeedback.org that I'll also link to later at the end of this presentation. And what this website is, it's just an aggregation of all of the different things that I found out in creating this presentation about how to set up OTel, about collecting observability data, about things that you can add and toggles that make sense, and some blog posts on the topic. So please feel free to look at that later if you want to recreate what I just talked about and see it in your own eyes. Okay, so let's go back to our problem. So the problem now is that we went from having no data to having almost too much data. There is a lot of data here. And this is just the data that I produced by making a few manual calls in a few minutes since we started this talk. How can we actually make this better? And this is the reason that when I took this tool and I took OpenTelemetry as a technology and I introduced it to my team, and I said, you know, guys, it's not even optional. If you are making a code change, you have to look at the traces and see what your code is doing. It's a part of your responsibility as a developer. How many times do you think my developers use this to examine their code? Any guesses? Yes. 0? 2. And I'll tell you why 2. There was one developer who tried it, found an issue, then he regretted that he found the issue. Because it was a can of worms. He did not want to actually troubleshoot all of these problems. And it led him down a rabbit hole. And suddenly, because he started working on it, everybody assumes it's his responsibility. And he was left with a lot of tasks. And he hated it. And he did not make that same mistake again. The other developer was smarter. He tried it twice. So actually, it's 3 times. The first time, he didn't find anything wrong with his code. The second time, he didn't find anything wrong with his code. So he said, well, by induction, if it didn't work the first time, then the n+1 also didn't happen. My code is perfect. I don't need to use that code. And that's the last I heard about it from my team. But what is the underlying reason? The underlying reason is the same reason why tests didn't take off at first. When I started, testing were not continuous. They were not automatic. You had to actually manually run the test. And it was this stage that you went through before you released your big release. And nobody wanted to be the one stuck running the test because they were, of course, they were red. And of course, he had to either exclude or fix them. And nobody wanted to be in that position. And only when tests became integrated into the process, you don't think about the fact that the test will run. They will obviously run. Then they became something that you could use and they became effective. So the problem with everything I showed you right now, and OpenTelemetry is key, without it, none of it would be possible, is that we created a very manual, a very reactive process to getting information and feedback about our code. This is a great science project. This is a great tool for somebody who has a lot of time on their hands and he wants to go in deeper about this code, or he wants to understand it better, or he wants to do some statistical analysis and remove outliers and tell me, you know, are we using the indexing efficiently in this database? That's a great science project for him. But this is not something that would integrate into the day-to-day life. And that is why I'm not surprised before when I asked you guys, do you think this would be useful to you when developing? And I showed you the trace. And nobody was very keen about it. So what is the alternative? And this is kind of where my own personal journey began with observability. So I came into this thinking, having 3 assumptions. A, that 10x developers I mentioned, I want more of these guys and I want to give them the right tool. B, we are missing a step and we're feeling the ramification. And C, there is a problem here, and it is something that can be solved. So, you know, there are issues that are impossible to resolve, but this is something that all it takes is to make something that is manual more continuous. And this is where I started working on a solution. That's why we started a project called Digma. I'm happy to report that since we started it, other vendors and commercial companies, we're a free company, we're creating a free tool, but commercial companies are doing the same thing as well. So you can see the New Relics of the world and the Datadogs of the world trying to do something similar. And I'm really happy about that because that's the push I'm trying to make. I'm not going to show you their tools because they cost money. I want to show you our tools because it's free for developers. And I think my number one frustration is that these same tools, the Datadogs of the world and the New Relics of the world, have been concentrating on that one aspect of monitoring production. And because of that, they've been targeting people who are not necessarily developers. So if you talk to some, it's not a secret. If you talk to somebody who works at these companies, you ask them, who's your number one user? So they may mention SREs, they may mention DevOps guys, they may mention IT, but they will not mention developers. I went to see this company in Israel, and I met with their VP of engineering. And this is, they have really fancy offices. I was walking down the hallway, and they had these big LCD screens lined all across the hallway, full of charts and graphs, the like of which I've never seen in my life. It was like really nifty visualizations of things. And I was like, you guys are so ahead of the curve. I cannot tell you, I need to learn from you. And their engineering, their VP of engineering tells me, you know, I have to tell you something. I just had a review meeting with one of my developers, and I asked him about the dashboards and how they use them. And he told me, well, I kind of always assumed that they were just screenshots. And I think the problem with that is that it's indicative of the state of observability today, because many companies follow the same process. SREs, DevOps guys, these are the guys who should care about how the code works in production because that's their job. Developers don't need to care about that. Every dashboard is oriented towards them, towards the infrastructure, towards the service, towards the business service. None of it talks about the code. So I knew I had to solve these challenges. I needed A, to make this a continuous process, B, to make it about the code. It shouldn't tell me that, you know, this service that I'm providing is not past its SLOs, because that's okay, fine. This just means more investigation time. It needs to tell me, you know, this code you just pushed, it doesn't scale, and here's why. This is what I'm expecting from a service that is targeting developers. And 3, it needs to be proactive. It can't be manual. I can't kind of go and look around and adapt. Like a dashboard is the absolute worst, because when do you look at a dashboard, right? You look at a dashboard when things are wrong. And even then, like, I was looking at these dashboards and they're saying, you know, CPU is 100%. Is that good? Is that bad? I don't know. Like, CPU is good. You want to use all of the CPU resources, right? So what does it mean? And this is the problem. The problem is that the solution space is not formulated to developers. It's formulated to other stakeholders. So what I want to show you now is kind of how we envision developers working with the same set of data, but effortlessly. And 2 things I want to mention about what I want to show you. A, that this is not a commercial tool, so you can download it tomorrow or today. It's a plugin in your IDE. 2, it's running locally, so it doesn't send any data to the cloud and doesn't abduct your data. It's just something you run locally. And last thing is that it's just at the beginning of the journey. So this is just launched, and I'm happy to say we have hundreds of developers already giving us a lot of feedback. We need more. So would really welcome any feedback you guys have as well. So let's go back to that same piece of code. And you know what? Let me actually run this small script again. So I'm going to find an owner. I'm going to add a new pet. Wow, quite an old pet. And then I'm going to go back into my code. And notice here, we have this telescope icon. I'm not sure if you can see it highlighted. And there's a green dot next to it, meaning there is new information. And when I click on it, I see information from multiple environments. And this is my test environment that I'm running right now. And I can see the same set of APIs that I was running. So let's take a look. at my rendering of the owner. And immediately, without having to look, without having to check the logs kind of reactively, I can see, I don't know how.
There you go.
Oh, okay. I can immediately see that there is an n+1 issue suspected in my code. Now, why did I need to go to the trace to look for that when something, some intelligent agent could be running continuously and automatically and always checking my traces for these types of issues? Always. It doesn't need to, if it's something that can be automated, we can't rely on people to do it. And here is the session in view, which is the other issue that we found out. Now, notice something else. I can now look at this specific issue, let's say the suspected n+1, and look at the trace. Sorry. See what the trace looks like. Sorry, it's my local n. But I can go from here and see the trace. So I don't need to have that same kind of starting by logs, trying to find an issue, and then going all the way back to the code. I can start at the code and the issue, and then see what the trace is that that shows me this particular problem. So all of this information existed all along. All I'm doing here is connecting two dots. I'm connecting the information that was there with the code. Now, let's take a look at another example. So I've been running some load testing as well. So I can go and look at this piece of code, and I can see that it's scaling badly. And not only that, I can see that a specific piece of code within that operation is the one that's causing me the problem. And I can kind of see where the bad scaling is happening. And again, this is a statistical analysis that anybody could have done, okay? This is not yet even data science. And we employ machine learning for other things like anomaly detection and things like that. But this is basic. This is, if I look at every piece of code that I have and I look at how it performs running concurrently versus how it performs normally, and then I scale that out and I create this graph of concurrency versus duration, then I can find out A, which piece of code is not scaling well, and B, which specific area in my code is not performing well. And in this case, it is this owner validation, validate owner with external service piece of code. And I can go there and see where it is and see that this is what's causing me all of that trouble. And this was detected by my test. Now, oftentimes you would use APMs and they would tell you, yes, things are past our SLO, this is slow. But then you would need to go back to your code and look at all of the things that are slow and find out which one is most important. And this is what we try to do, to take the code as the first class citizen here and not look at the code as kind of an artifact. So what that allows me to do is it allows me to look at all of these different code assets. And this is the data model that Digma keeps. So we have here database queries, we have endpoints, consumers, HTTP clients, and so on. And we can look, for example, the database queries, and we can sort them by performance impact and understand which ones are the ones that are slowing me down, not which ones are slow. That's easy. But something could be slow and being used once in a blue moon and not affecting your system that much. But if I need to optimize, then I need to look at my code and see what is making a difference. Again, all of that information, this is the amazing part to me. Like this, the thought that I had was, how often does it happen that some big trouble happens and then we look at the logs and traces and we say, of course it was there. Like the logs were saying it all along. The traces were always saying there was an issue here. But that comes after the fact. So why do we need to have that hindsight vision where we can always take a look at these issues? And this was hiding there. We just uncovered it. It's hiding there in plain sight. So 3 things were solved here. First of all, I didn't even touch on that. We removed the whole how do we enable OpenTelemetry thing from the equation. So we just added a toggle. This is a plugin that you add to your IntelliJ. We added a toggle called observability. It can be on, it can be off. That's it. And if it's on, it means we do all of the boilerplate, we automate all of the boilerplate of downloading the OTel agent, or if you want to use micrometer tracing, you can use that as well. Download it, enable it, set the service, everything. No need to do anything except switch that on. So we've removed the barrier from that it takes for me as a developer to try this out. Second, we just start processing it all the time. And now the question becomes a different one. What do we want to look at? What do we want to find out? And our source of truth for that is the community. And this is why we decided that this should be a free tool, because the community tells us what they're interested in. So the community told us about the fact that they miss N+1 queries. And the community told us about the fact that they want to see where the bottlenecks are in their requests. And the community told us that they want to find out regressions. And the community told us, I'll give you a really great example. This comes from a big e-commerce company. Let's just say it's the second biggest after Amazon. And I talked to this guy there. He's a champion, really. He's this guru guy that they call to start, like his entire job, they call him in, he starts a new project, he tells the team how to solve the problem, then he moves on to the next task. So after I told him how jealous I am of him, because he doesn't have to deal with anything, he just starts the job and everybody needs to deal with everything that happens later. I asked him, like, you have all of this data, and he's already using OpenTelemetry and everything. What is the number thing that you would want to get out of this data that's hard for you? And he told me this another amazing story. He said, in the company where I work, which is this big e-commerce platform, we often run background, like batch jobs, and we scale them concurrently, your threads, processors, and so on. And he said, do you know to how many threads do we choose to scale any given task? Do you guys have a guess? Well, I'm not surprised, because it's a random number. It's 100. So every single task that we want to run in parallel, we run 100 threads. And he asked me, do you know why it's 100 threads? I said, no idea. He said, well, about 7 years ago, there was a developer, he introduced a constant called default concurrency level in the code base. And everybody is referencing that constant ever since. So you would think somebody in a company our size would do the research. What is the best concurrency? Is there critical sections here? Maybe the concurrency is not even helping because it's locking a database table or whatnot. But no, there is a constant, so everybody will use that. Now he said, you know, if you look at my data, I am pretty sure that you'll see that of the different concurrency levels that this code's run at, because it's not always that I have 100 tasks, sometimes it's less, then you would be able to tell me, am I gaining something or am I losing money here? But to do that, you would have to look at the data again. And that's something that just requires 3 things. It requires creating a backlog item, assigning somebody, and prioritizing that. And as a product manager, I always care about the next thing. So it doesn't happen. So I told him, okay, let's do that. And we're going to roll out this feature next month, which is amazing to me because this is actual value that comes from a developer that saw a problem. And this is what we're iterating on today. Like what we're doing now is really taking different problems, the same type of problems. Yeah, okay, now we can see. I don't know why it didn't work before. So here you see I can go from the problem and actually see what the trace looks like. But as opposed to what you saw before in Jaeger, this is connected to my code. So I can go from here into the code and vice versa. So we took the same trace that we saw before and we just overlaid it on top of the code so you can move from one to the other. And why does that help you? Because you can answer other questions. And these are the things that come up all the time because suddenly when you have access to this data, the questions you can answer are not ones that we thought to pose in the beginning when we didn't have it. For example, you can look at a piece of code and invert it and say, okay, who's using this code in runtime? not static analysis, not looking at who's using this function and then going back and back and back and back, but just looking at, if I change this particular code, who might break? How are they using this code? Things that are very hard to answer become something you don't think about. And I will tell you about what we've seen, having practiced this in the field and having rolled out this to developers, that we often get the question when we disable it, that people feel that it's kind of like something they got used to it because they shouldn't need to think about it, right? If I look at a function and I'm used to the fact that I can always see runtime information about it, that I can always see whether this is this crucial step in the process that I should be paying extra attention to, or this derelict place in the code that is actually never reached, right? Which is also important. So these are the things that once I have access to them, it's very hard to see the code in the same way when that piece of or layer of information is removed. And this is where we know that we're providing something that aims just to be transparent. And that's why I told you before, I don't think people should care about OpenTelemetry, because whether this is running OpenTelemetry or a Java profiler behind the scenes or micro profiler or anything, it doesn't matter, right? The point is that we can get the information easily and we can make it into something that's actually useful. Before I move on, I'd be very happy to hear if anybody has questions. Sorry? Digma.
Repeat the question. What's the name of the plugin, Digma?
So yeah, it is Digma, and it is just in the marketplace. So all you need to do is just search Digma, and you'll see it here, and just install it. Yes. Any other questions? No, it doesn't exist for Eclipse yet.
Eclipse, is it for Eclipse?
Not yet. So far we're just on IntelliJ. The reason is because it seems like 90% of Java developers are using IntelliJ right now. We'll get to Eclipse as well. Yes.
Can you use the same tool for production issues?
That's an excellent question. So let's talk about production. First of all, yes, it's the same platform, but what we see happen with production, like this is kind of like a few containers running on my laptop, so I don't feel it. But if I needed to ingest, millions of traces per minute because it's a large scale production system, then probably I would not want to send these traces to my specific laptop, right, from production. So that's why if you want to use it with production, we just have this Helm file, just deploys a Kubernetes deployment that is the same Digma, but just scaled. So it has Kafka and Rabbit and all sorts of scaling properties so that it can create more workers and process more work if needed. So it's more scaled towards production. So if you want to do that, you can deploy it anywhere in your private cloud and then just send the information from production there and then connect from the IDE in the same way. So basically in the plugin, I can say, which Digma do I want to talk to? My local one or maybe a central one that I deploy somewhere. But this is something that we're using all the time. So we have our own kind of SaaS instance that we're just using locally. And we're improving that all the time. And a part of the way that we use to improve that is we connect to it and we check our code all the way through. Any other questions?
Does the OpenTelemetry jar file come with the JDK, or do you have to get it separately?
So the OpenTelemetry jar file is just an agent, just a Java agent. So you just add it as another VM options or the environment variables, just a way to set VM options indirectly, but it's the same thing basically. But there are several ways to use OpenTelemetry. Maybe I'll talk about that just for a sec because it also relates to the previous question. if you're using OpenTelemetry and Dev and Test, I would 100% recommend you use the agent. Why? There are two benefits. One, it doesn't require any code changes. I took the same code, I added this environment variable, and I have same code plus data. Second, it has this really wide support matrix. So all of these libraries are just automatically going to be sending out information. That's great when you're in Dev and Test. In production, you probably want to test out the impact to performance as well. So, just like with logging, if you overlog, then you may hurt the performance of your system. So for production, for Spring applications, especially, I would recommend there's a micrometer tracing project for Spring Boot. And what I like about it is that it's absolutely not magical. It doesn't use reflection. It doesn't use any bytecode stuff. It just uses built-in properties within the actuator, within Spring to get that information. So it's very, very performant, and it's very easy to set that up as well. But that does require a code change because it requires adding dependencies. And Digma can configure it for you, but then you'll need to check in a code change. And B, it's less magical. So here, all of the libraries are going to throw information out there. There, I need to kind of tell which libraries what to send them.
Just a quick time check. It's 7:55 p.m.
Okay, cool. So the last thing, and I'm still here if anybody wants to talk later or ask questions. The last thing I want to mention is I wrote or I rolled out this Udemy course about the continuous feedback. And if anybody is interested in that, I just write me an email. My details should be here. Okay, they're not here. So my details are on the continuous feedback page. So just write me an email. I'll send you a coupon so you can get it for free. And it just double clicks on some of the topics that I mentioned here, and goes a little deeper about the capabilities of OTel, about tags and attributes and different things that you can add as well to get more information out of your spans. So it's another kind of resource that could be useful. Cool, that's it. Happy for the opportunity to speak and to meet with everybody here. And if you do end up kind of fiddling around and seeing what type of information you get about your code, do let me know. I tend to practice continuous feedback myself, which means I try to get feedback. And the feedback that I prefer is negative feedback. So if you call me and you say, hey, it was a nice tool, then I will be happy but kind of disappointed. If you call me up and you say, this is crap, I really hated it, why did you do that? Then I have something to work with and I have some stuff to fix. So be very direct and tell me everything that worked and did not work for you, and I'll be very grateful for it. Thank you. Thanks, everyone.
Thanks, Ronnie. In terms of feedback, it's 8 p.m. and you have a room full of people, so I would say good job. We're going to formally end things, so bye, internet people. For those of you who are in the room, we are doing our usual raffle.